Okay, this will be the next section of our little series, helping you get ready to solve your statics problem for Engineering 1100. What we're going to talk about here are creating and constructing free body diagrams from given problems. What we have here is we have a mass suspended by a rope, which is going over this pulley and attached to the wall. And we're going to say it's not moving. We're going to keep this one simple. The point of a free body diagram is going to be to take this and visualize the forces acting on it at all points. So first we have to understand which forces are acting on this body at any given time. And what we see is we have a tension in the rope going this way, right? And we also have what? We have gravity acting at all points on it at all times. So we have the force of gravity, which is mass times acceleration due to gravity. And as a note, typically if you see the letter G in a problem like this, it will equal 9.81 meters per second squared. And that's why we need the mass to get a true force in newtons, which is kilograms meters second squared. That's a side note, but nonetheless very, very useful. Now, I've made this drawing and I've drawn these forces randomly. Well, not randomly, but they're not really connected to anything. So what we can do then is we can take it, and I just want to look at only the body. I don't really care what's happening at the wall, and I don't really want to know anything about what's happening at this point here. I just want to look at our body, M. I know it's not the same, but it's close enough. This is just M. And at M, I said I have two forces acting on it. I have the force of the tension of the rope, and I have the force of gravity, mg, acting down. Now this is all of the forces acting on this body M. This is good enough for a free body diagram. If you were to want to make it a little bit simpler, and you were like, well, I don't like drawing boxes, well, then it will be acceptable if you want to say, at least in a problem like this, that there's a point M, because that's just going to be defining our box, and typically it'll be the center of mass, through which all these forces are acting. And so now we have just a very simple diagram of the forces acting on our mass. And this will greatly simplify many problems, as you'll see later, when there's multiple forces acting in multiple directions with different variables defining them. This was just a simple illustration of how to start.